For those of you who don't know me, I'm a sales guy effectively these days. I'm titled CTO, but typically I'm doing pre-sales, so I'm used to clients jumping in with questions and getting interrupted, so feel free. What am I going to talk about today? So effectively, I got asked by Tom to talk. I started to think about what can I talk about, what's really cool to do. And then I brought it down to something really boring. The reason why I did that was because I got a lot of clients, so I'd effectively say I've got the white pages of CVs. Being a consultant, I work with everything from a tier 1 bank to a 2-person startup. And one of the things I see is, and we're an Amazon consultancy, so those who don't know, we're CMD Solutions, we sponsor the meetup, we're a DevSecOps consulting company. But what I see is people really suck at AWS IAM and authentication models in general. So what I want to do today was talk about just some really simple things you can do to improve authentication. Once everyone I see is doing that, we'll talk about something cool. So I'm Adam Durbin, CTO of CMD Solutions, one of the co-founders about 4 years ago. As I said, DevSecOps consulting company, do a lot with AWS. So all of the concepts I talk about today, completely Amazon, just because I was lazy and I didn't want to have to go terminology change between another cloud vendor. But they're very portable. So everything I talk about is more conceptual, and we'll talk about how you can move that between whether you're on-prem, whether you're on cloud, whether you're whatever it is. I'm an Amazon APN warrior, cloud warrior. I've been one of the APN warriors for about 4 years now. It's one of the partners. There's about 25 in Australia. Effectively just one of the people who has been working with Amazon for a long time, number of certifications, etc., etc. I've designed and implemented a large number of AWS environments. I've been involved in 150 plus projects, I'd say, over the last 4 years, whether that's pure oversight or whether that's hands-on delivery. So a vast experience and seen a lot of different environments across a lot of different security pillars. So when I talk about security pillars, things like PCI, IRAP, ISM, government side, HIPAA, whether it's Australian, GDPR for European, and all of these have different security control requirements and authentication things that you should be doing. But even if you're not under any compliance requirements, no one wants their data leaked. No one wants to be the next one on news.com.au saying, data breach, 10,000 credit cards leaked or 10,000 people's personal details leaked. So these are things you can do to try not to be on that list. So Amazon have a large range of AWS services. I wanted to go through and started talking about each of them. I figured I'm not going to. There's too many to talk about. What I'm going to do is cut it back to a small list. But what I wanted to do was really just categorize the sort of services that Amazon have or any cloud vendor or security service can do. So typically you break them up, or Amazon break them up in this way. So I followed their pattern. Authorization. So authorization is really authentication and access. But more around, not so much authentication, but more about who I am, how do I authenticate, do I multi-factor, what permissions do I have once I'm in. Detective. So detective are things like an IDS, intrusion detection system, or in Amazon terminology like guard duty is kind of a lightweight IDS. Inspector for vulnerability scanning and management. Security hub for a single SIEM view of your security information events and alerts. Shield for your DDoS protection. And Macy for basically crawling for sensitive data on your buckets and publicly facing systems to make sure you're not accidentally leaking something like credit card data. So there's some of the detective services. Auditing. So one of the key things about security, it's not all. You need to be good reactively. Even if you don't have the proactive things in place, you need to be able to audit and track what has happened in the past. It's too late if you've already had a breach and you go, oh, now I want to turn on CloudTrail so I can see what API events have happened. Or now I want to turn on config to see what the state of a service was, to see what has happened during the breach. It's too late, right? These are things you should do day one straight away. Protected data. So protected data is really around encryption. I think about in-flight encryption being ACM or at-rest encryption being KMS. Or a secrets manager where you can encrypt secrets so you can securely access them. And authentication. So authentication is really around that sign-on experience. Single sign-on and Cognito are the two main services. So what am I going to talk about? I'm actually only going to talk about really IAM and the supporting services that support IAM. So for those of you who don't know, who works with AWS today? How many? That's a good range. Who knows what IAM means? Come on, if everyone doesn't know. Identity and access management. So effectively it's the I'm a user, I've got permissions, and it's a policy. I'll give a bit of an anatomy of IAM, just so people are, if I say concepts, you've got an idea of what I'm talking about. So a user is a user in IAM. It's like an Active Directory user. If you use AD, it's a named person or service account with access into AWS. They can really go in two forms. IAM isn't just people access. It can also be system access for systems generally that aren't in AWS. If you've got an on-premise Jenkins server that needs to deploy services to AWS, that's an example of where you may have an IAM user that authenticates in using secret keys and access keys to the cloud. So as a user, a role is actually the better way to do access once you're in Amazon. So if you've got a really native AWS environment, you want to use roles as much as possible. And basically, user is a four-letter word. Don't use users. We'll talk about what they are, but effectively you can assign them either to people, and people can assume a role, or you can assign them to services, and the services can assume that role. What it gives them is short-term access to do something. Usually it's time-bound by about an hour using SDS, or longer. A trust policy. So there's two types of policies. Well, three if you count custom policies managed, but a trust policy is what is allowed to use that role's policy. It's a bit complicated, but let's pretend I'm allowing access for a role that I create for Amazon config to use my role. So it's allowed access to my account to view logs or to look at a bucket or to put things in a bucket. That's what a trust policy does. It gives something else access to a role. And we'll go through some examples of that later. Managed policies. The reason why I've distinguished between managed policies and custom policies. So managed policies, AWS have a number of policies they create and manage on your behalf. So those policies usually come in two formats. One format is more of a role-based policy. That role-based policy is I'm a developer. Okay, so what does a developer normally need to do? But these are Amazon managed. These are not custom to your organization. These are, they've got to make it generic enough that most developers, in most organizations, that would work for them. So that's where they're a little bit more open than what you would typically expect a custom policy to be. A custom policy is a developer in CMD needs access to these services and these functions because that's part of their role. So that's custom policies. Permission boundaries. So permission boundaries, one of the main limitations of IAM over the years has been the fact you have to give access to IAM to do other things. So you have to give access to be able to create a user, create a role. What does that mean? You can create a user to be an administrator and then use that user. Effectively, it's a complete backdoor into opening access to yourself to do something else. If you can create a role and attach a managed policy to it, you can effectively make yourself an admin, right? So what permission boundaries do is effectively allow you to wrap that you can't give something you create more permissions than what you have, or you can bound those permissions to be low. So I can create a user, but it can only attach these roles, or it can only attach these permissions to that user. And service control policies. They're really not part of IAM, but they're worthwhile talking here because we'll delve in later. They're a AWS organizational construct. From what I've heard from Amazon, service control policies and organizations are actually going to replace IAM. It's kind of like a rewrite of IAM because IAM was written 7-10 years ago and it needs evolution, but it's so ingrained into everything they have, it effectively needs kind of a rewrite under the hood. I don't have evidence of that, I've just been told, so off the record. Service control policies are complete account level permissions. So these are great if you work in a regulated environment. You work in a bank. You work at PCI data. That PCI says you can only use 10 Amazon services that are PCI approved by an attestation of compliance. How do you stop someone using those other services, or how do you whitelist? Service control policies does that for you. You can say, I have 10 services people are allowed to use, they can only use these 10 services. Or, I have a specific service I don't want people to use. It's not approved by my organization, it's heavily, let's pretend it's Sumerian, the AR service from AWS. You've got no need for it. No one would possibly need to use it, but it could run up costs, people could do it for fun, whatever it is, so you want to block that service. That's a way at an account level to say even administrators can't use this service. You can also start to do things now like boundaries on regions. So service control policies are brought in conditions, so you can start to do only allowed to use Sydney region and the US region, or just Sydney region, so people don't go global. Cool. So what do I see and why did I start this talk? Typically there's 3 maturity levels of AWS security and IAM specifically. There's the basic customer. They've started out in Amazon, they use IAM, they have some access keys lying around on people's machines, they've got long living users, no user password rotation set, they're using Amazon policies. Typically they've got a full admin user and a read-only user. That's all they do. Everyone is full admin because everyone needs to do everything all of the time. And they're generally simply over-permissioned policies. So too much access for the user. They don't need that much. So that's the basic security. That's where people start. And then people either have a breach or they need to kind of compliance audit. Something comes and they go, okay, how do we move that up? So typically they move to a good practice style environment. They link to identity federation. So they start to use Active Directory as their centralized identity source, or Google, or Zero AD, one of these identity sources, and they link to that. So if someone leaves the organization, they don't have their access follow them, and you forget to go delete their Amazon IAM account, it follows them with whatever the central identity source is. Much better for user lifecycle management. Centralized identity account. Typically they'll move to, okay, it's actually easier to control permissions and access if I push it through a hub. And I control users in a single place, I control access in a single place, and then I use Amazon's ability to cross-account, assume role, to then federate the access into multiple accounts. Typically in basic security, they've got one account, right? It's their prod account, it's their dev account, it's their identity account, it's everything. IAM roles, they start to move to roles. Okay, keys are bad. I'm going to assign a permission policy to my server. It's going to have direct access. I don't need to give it long-living access keys and secret keys. They then start to look at granular policies. Okay, not everyone needs admin, but we're going to give them a policy that I define. At this point, though, they're probably not using things like conditions and boundaries. And they hopefully are starting to remove the use of IAM's keys, shared keys. In my opinion, shared keys are the riskiest thing to an organization, apart from open S3 buckets. Everyone hears about the open S3 buckets, but access keys are a static credential that you can use anywhere if not created properly. If it leaks, a lot of people have checked these into GitHub over the years. Amazon have crawlers now constantly looking for access keys that people accidentally check into GitHub because it happens and people get their accounts attacked. So hopefully they're starting to remove those keys and start to move to a federated model. Cool. And then you get to the best practice environments. These are typically customers that have a really good lens on security. They've got confidential data. They're under a compliance regime where they need to be secure. So start to move towards time-bound access. And that's one of the things I'll talk about today. Not many people we see are actually using good time-bound access. So I'll give an example of how you can do that quite simply. Fine-grained policies, but with conditions and boundaries. So policies are all good to say you have access to this, this, and this. Conditions and boundaries, which we'll talk about, let you go deeper than that. Let you go, you have access under these conditions, and we'll talk about what they are. An approval flow for permissions, privilege escalation, sorry. So one of the things that often happens, I'm a developer, I need access to production to go fix something. Cool, here's the admin role. No one ever takes it away. There's no formal approval flow over the top of it, and there's no tracking to make sure it comes away from me once I've finished that task that I needed to do. Review and cleanup, typically, no one's looking at it, right? It's a completely additive security model. Everyone adds permissions all the time, no one ever removes it, no one ever cleans it up. Resource access sharing. I didn't actually talk about resource access sharing in the future parts, but effectively what that lets you do is use things like network services, like a VPC or a subnet, create that into one account, let a network team look after it, and share those resources to other accounts. So you can centralize that in an account level for things like networks and VPCs and subnets. You can do that as well with like RDS and databases. Lots of services are starting to support resource access sharing. And monitoring, real monitoring and dashboarding of what is happening across the environment at a security level. Who's logging in, how often are they logging in, what access level are they logging in with. Understanding this information is key for not only predicting but also reacting to a security event. Permission hierarchy. So this is actually an Amazon picture, which I snippeted and dropped in because I'm lazy. But this shows you what the different authentication controls that I talked about before, how they bind together to give someone an effective permission. Right. So an organization's SCP, their permission boundary, and their identity policy combined, the middle of that Venn diagram is the access they have. So if I deny access for an SCP, it's not in that Venn diagram. So it gives you, the cumulative of those three services is your effective permissions. Now some tips. So how do you go from basic security up to best practice, or at least to good security? We'll go through each of these, so I won't talk about them now, but effectively I'm going to talk about multi-account patterns. A lot of people would go around, still have one account or two accounts, and that's it. Unfortunately, it's still a bit of a burden, but it's not as much as it used to be to create more accounts and manage multiple accounts, but it is a good security boundary and you should use it. I'll talk about why. Centralized identity, that hub-spoke model, we'll talk about how that works. Conditions and boundaries, what we call break glass, but it's really time-bound access, giving someone access for the period of time that they need it only. And MFA. Cool. Multi-account architecture. Often go to customers and they say, why do I need multiple accounts? This just sounds like it's adding a lot of complexity to my environment. Do I really need to do it? Yes, but a lot of people go too far. A lot of people start saying every user needs their own account. Every application needs its own account. It's a sliding slope to making your environment too complex by adding too many accounts. So really, there's a couple of tipping points on why you would add another account. I'll talk about those, and some of them are security, which I've boldly read. Cost reporting. To the dollar cost reporting within cloud, and specifically within Amazon, is very hard at an account boundary level. So if you want to get that $2 reporting, typically, business unit A needs to know their dollars because they pay the bill, versus business unit B, you separate them at an account level. Security boundary, IAM, you'll see, is very complex. It's not a simple service to create a policy which allows you to do certain things in account and not other things, or only access this VPC. It's really hard, and you'll stuff it up. People have too much access, or they'll constantly be coming to you for change because it's just too hard. Environment segregation, as of always, it's been good to separate your non-production from your production. Right? You have a lot more open permissions in your non-production environments. Separate them at a network level. Separate them at an account level. Business unit separation, similar to cost reporting, but it could be for merger and acquisition purposes. It could be for isolation of two businesses where they don't need to share data, separating those two. Blast radius. Someone gets root credentials. Right? They get root credentials, they blow away absolutely everything in that account. One example I give customers is, imagine if you have the backups in that account as well. They've now got your systems, running systems, and your backups. You're gone. So what do you want to do? You want to separate your backups and your logs away from your data. That way, if someone does manage to compromise your main production account, it's bad, but at least you have a cross-account boundary permissions and a separate account with your backups and your logs. You can figure out what happened, and you can hopefully recover as well. Compliance, there's good reasons at a compliance level, such as PCI and IRAP, why you separate your compliant workloads from your non-compliant workloads. Otherwise, you'll drag your other workloads into scope for simple things like authentication, or if you connect via network, even more in scope. So separating those two things apart has great benefits from a compliance and auditability point of view. The last one is limits. Limits only really come into account when you're big, right? If you've got tens of thousands of EC2 instances, tens of thousands of serverless, you've got hard limits you'll hit within a single account that you need to be aware of. Typically, when you start to get that size, it's better to start to break apart, and you start to think about the other whys and how would I break it apart. The hows, I'm not going to go into it deeply. The typical one we see is at a minimum by environment type, dev, test, pro. Right? You've got a simple way to separate your accounts. MFA, still one of the least used things that I see. I don't know why. People don't enforce it. It's so simple to set up. So we as CMD use Okta as our identity provider. So we enforce MFA through everything that we do using Okta. You can do it with IAM users. So even if you don't have an identity provider, you can still enforce MFA. You can create simple policies which say you can do nothing unless if you have an MFA token turned on, but set up MFA. So the user can log in, but they can't do anything until they turn on MFA. So it lets you set up that very, very simply. Typically, Amazon Authentication uses SAML, so anything that supports SAML and any identity provider you have, you can get MFA set up. Also, the command line. A lot of people say, okay, look, I've got console level, I've turned on MFA, great. I'm secure. But then they go set access keys and secret keys for everything they do at the command line without MFA. The command line is probably the more vulnerable way you're going to get attacked. Anyone smart enough to attack your account is going to know how to use access keys and secret keys. They're going to be much faster at attacking your account via an API or a CLI than they are via a UI. So making sure that if you are turning on MFA, you're not just enforcing it for the console level and saying, oh, look, people can still go use the UI and CLI, so the CLI and API without MFA, because you've basically done half a job, if that. Centralized identity. So we'll talk about Freddy. So Freddy's a developer. Freddy has to get access to production for read and non-production for, he has to put things into a bucket to do some testing because he's got some application that requires it. So he needs 2 levels of access into 2 different accounts. One way to do it, Freddy gets access into 2 accounts and he can log into either account. Another way to do it is using a hub-spoke identity model. It could be 2, it could be 100 accounts. The key here is you've got one place to audit what Freddy can do and what accounts he has access to. Using that centralized identity account, you can turn on things like guard duty, you can set up dashboarding around logins, you can do something centrally in one place which gives you a good visibility on who's in which environment, how they're authenticating. So typically you do that by setting up a IAM policy or role inside the identity account, which all it can do is assume role into other accounts. So once Freddy logs in, he says, okay, I want to go to production. In production, Freddy has the permission to list objects only. All he can do is see what's in a bucket. He can't download the file that's in the bucket. He can't change the file, but he can at least do some troubleshooting and debugging if something hasn't happened that he expected. Or in non-production, if he logs in with that exact same role, he has elevated permissions. Using the sort of RBAC model, in non-production, read-only, in production, read-only, in non-production, slightly elevated where needed for their job role. Conditions. So conditions are very rarely used from what I see. And there's some very, very simple conditions you should use in any IAM role you're creating for specific purposes, like, let's talk about CI/CD runners. It's a very common practice where they have their runners running on a cloud service. The cloud service doesn't know, like let's say GitLab.com, GitHub.com, they're creating access keys and secret keys for the runner or the CI process to create something into cloud. When you do that, you just create an access key that says it's full admin, drop it into your CI tool and you're done. With no permissions on it, no conditions on it. Conditions can be done in things like IP whitelisting is a very good one, especially if you're coming from an on-premise enterprise environment and you only expect an S3 bucket to be read from your network. There's no reason anyone outside of your network should be using it. Put a condition on there for IP restrictions. You can do the same for VPC endpoints. We've got a lot of customers who have PCI data and they push credit card, use S3 as an intermediary for processing credit card information. One of the best things you can do to make sure you don't become that next article on news.com.au is restrict that bucket to only be able to read from within a VPC. It's very hard to get access to it outside of it. You can turn the policy off as well. The bucket policy say it can't be read publicly, but that extra layer of permission means someone, even with authenticated IAM permissions, can't access it from outside of the VPC. It gives you that extra permission boundary, that extra hop. It's all about defense in depth. So who knows what the defense in depth means, right? There are multiple controls to achieve the same outcome. So if one control fails, you've got another control there. If that control fails, you've got another control. It's all about building a boundary. So if someone, they do get credentials, they still can't get in. Other conditions you can use is things like tags, time periods. If you're only expecting people to be SFTP in a file to a bucket between this time period, restrict it to that time period. If you only want HTTPS transport, conditions, secure transport protocol must be on. These are things you can do just to improve your policy. Effectively, the effective permission is the same. It says under what conditions are you going to allow someone to use that policy or that role. Review and monitor. IAM should not be an accumulative security service where permissions are continually added but never reviewed or removed. I can't stress that enough. So many companies add permissions, add permissions, add permissions. You know, everyone needs everything all of the time, right? You always need to be a full admin every single day of your day job. No, you don't. Use things like Access Advisor. Okay, I've given someone this permission, but they've never used it. Let's take it away. You know, if it's got secure data and their credentials get compromised, what's the risk of that if I take away their permissions down to the minimum that their job needs? And then have a good, easy way that they could escalate their permissions if need. So the two services from Amazon that, you know, one of them's relatively new, one of them's been around for a while. Both of these are now, I believe, supported by the API as well. So you can start to do some automated dashboarding, reporting, logs around this. Access Advisor. So Access Advisor gives you, I've got a role and it's allowing another account permission. All right, so I'm actually granting someone outside of my account permission into my account. It's one of the ways, you know, things that like cloud health or cloud conformity or any of these, you know, third-party tools where you may give access into your account. What if you stop using that and you don't realize that you've left that permission open, or you've created a star policy where any account can access your account? You need to be, you know, checking this Access Advisor and Access Analyzer, and making sure that if you are giving permission to roll outside of your account, you know about it and you mean to do it. Access Advisor. So Access Advisor says, I'm a developer, I've got a developer role. It says I have full access to S3, but I've never used S3. Okay, why do you have full access to S3? We have our backups in S3. Do you actually need it? No, let's strip that out of the role and let's, you know, harden that role. Time-bound. Time-bound, I think, is one of the best ways with an approval flow. So time-bound is, okay, I'm a developer. Production is having a major issue at the moment. I need access. Okay, let's get access for the next hour to go troubleshoot. So building an approval flow to give you the access that you need at the time you need it when it's a production service. Not, okay, I'm a developer, I may need to fix production one day if it goes down, so I always need access to production in that event, unlikely event that it goes down or I need to jump in and troubleshoot. So how do you do that? Building a model where you can add access or give access to someone for a restricted period of time. So effectively, our principle is you should only ever have read access in prod or long-livingly. Okay? Why are you doing things in production? Your CI tooling should be doing it. Your automation should be doing it. Someone else should be doing it, not you. An automated process should be doing it, not you. It also gives you much more trackability and auditability around who's going to production. We've used this with various customers, and they actually exception report on anyone that's gone above, you know, using the break glass process. Why did they do it? Why is this not automated? Why did they need to make a change manually? So you start to be able to go to the root cause of why people are doing things in production around your automation. Cool. So two examples. As I said, it's very simple to set up time-bound access. So everyone should be doing it in some way or another. Most companies are using Active Directory as an authentication source. It's pretty much the standard, or some identity provider like Google or Azure AD. The way they typically work, you're part of a group, or you're part of a group generally, which says you have some level of access to Amazon. So what you can do within this is say, okay, I'm going to create a group for prod access. I'm going to build an approval flow where if someone requests prod access, they get added to that group for an hour, hopefully via automation, not someone doing this. So Freddie says, okay, I need to get into production. He raises a ticket or Slack message or whatever your flow happens to be. That either goes to an automated flow or that goes to a person. They give that access. They do Freddie does what he needs to do, goes, fixes the problem. Time ticks, tick, 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 tick. After the hour, 24 hours, whatever's been granted, that access is removed. Cleans up the access, cleans up the risk of, you know, someone getting Freddie's credentials. Very simple way using Active Directory. What do you mean? You can build automatic extensions. So this is the second model. This one will be more built to be able to do automated extensions. This is one I'll demo. So this is one that we actually use within CMD. This is not group-based on ticket. This is, I'll explain the process. So effectively, me, Adam, I need to log into a customer account. We have lots and lots of customers. I don't need access to every customer all of the time. So don't give me access to every customer all the time. So what we do is say, okay, I start a CLI session, I authenticate myself to our identity provider, which is Okta. I then have a read-only role. Great. I can go look at customer accounts, do any troubleshooting I need to do. Okay, there's a problem in a customer account. I need to log in and make a change. That should go through an approval flow. Someone should know I'm doing it because I should have an approved change to make a change on a customer account manually. Otherwise, it's gone through Git and approval flows like that. So what happens from there? I execute a script. I choose which customer I need access to. The role that I have access to is read, has access to also kick off a step function within AWS. That step function basically kicks off an automated workflow. That automated workflow sends a Slack approval request to a secure Slack channel where a small number of approvers are in. They choose yes or no that I have access to that account. Step function gets that approval, continues the step function, moves to the next step, adds a role in the customer account specifically for me. And that's key because it's a named role for me, adam.durbin@cmdsolutions.com.au. Only I can use that role. I'm not breaking glass for every single person in CMD, just me to do that. Multiple people can do it once. And then it waits. So then step function pauses for 24 hours and then after 24 hours removes. We do have customers where we've built an extend, right? So say I've requested it for an hour, I'm not quite done with my task, they basically send an extend request. So using this model, yes, you can get I didn't quite get long enough to complete what I needed to complete, give me more time style request. Cool. So I'm going to demo. It's very boring because it is just getting authentication to AWS, but I'm going to do it anyway because I didn't have time to do another demo. Oh mate, live demos everywhere. Cool. So I'm just going to demo that flow and show it do two things. It's going to suck with the mic. I'm going to put this down. Yo. So quickly, what I'm going to do, I'm just going to break glass to CMD lab-test, just one of our lab test accounts. Cool, it's derived the client name as CMD lab. I actually did this earlier, so I'm hoping I don't already have a role. Auto approved. What this is doing is logging into the other account. So we have nothing deployed in the customer account. We just have cross-account permissions to our identity account. So nothing long-livingly lives in that account to make this all work. It's just cross-account permissions from Amazon and a step function. Logs into the customer account, creates me a role. That takes 15 seconds. That role we've actually got by default to last 24 hours. Right, so I get a day where I can do something for a customer. Typically, if I'm doing something, I'm working on them for a period of time, and off I go. I'm going to kill that because I'm going to do it in one which requires approval. So same process. Management account. This is one of our internal accounts again, but this is what we would class as production, I believe. Cool. pending approval. I just realised I need to go to Slack to make this happen. Hopefully nothing comes up. Everyone close your eyes for 30 seconds. Oh, it's only message to Thomas. Cool. Break class admins. Cool. Approve. I can approve. I'm part of the admin's approval. We have with other customers built-in things so I can't self-approve, but we haven't done that at the moment. We've just got a small list of people that can do it. This all tracks. That then goes and creates my role. Once I've got a role, I'll show you how we can examply use that role. I'll just use the console just because it's easier. Probably should have showed you guys this not work first, right? But anyway. So I want to go to run CMD management. As I said before, we get a role named for me. So break class adam.durbin@cmd.com.au. So this is specific to me. I log in and I'm now in that customer as a privileged user. If you have a look here, that's the unique ARN for the role that I just created. So it gives us a time bound. I'm not going to wait 24 hours, but if you want to come back at 6:51 tomorrow, I can prove that role's been deleted, and then I lose my access to that account. Cool. Any questions? So I guess the point of today's talk was more to say, there's some simple things. I'll drop this up on slides or somewhere so you can go to the pack. There's just some simple things you can do to really improve the posture of your environment, which don't take months and years to set up. I've seen a lot of customers spend a long time trying to do very complicated things to secure their environment, which actually make it less secure, or they never get to the outcome they're wanting. And look at some very simple ways you can do it first, set those up, and then if you need to be more complex, be more complex. Good. Shoot. Yep. Correct. It's just a Docker container with a bunch of pre-set up utilities, effectively. It is open source. It's on Docker Hub. You can CMD Solutions / command line. Looking for Jason. Anyway, yep. 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 Yeah, so the question was, everyone says I want all of the access all the time, or I want all the access, right? My application needs to do everything because I think I'm going to use every single service. There's a couple of ways to approach it. Typically, I'd say to the person, why? Give me what you're using this service for. Let's talk about the permissions and let's try to not give every bit of access. Really persistently, they say, no, I need it now. You can give them the access and then review it after a very short period of time and basically show them, look, you're using this subset of permissions. Is your application working? Yes, great. I'm going to cut it down to those permissions. And you can typically that should happen in development and a non-production environment. I'm hoping everything goes through a good dev lifecycle. The same level of permissions you need in non-production should be the level of permissions you need in production when you're talking about things like applications and services. People, a little bit different, but applications, that same dev lifecycle should work. Access advisor, the one I brought up earlier. Yep, that role is any role. It can be a service role for an EC2 or a user role. Yep, every role to Amazon is the same. And you can, we have written automation to API, pull that out as well, build CSVs on it. One of the good things to do is build like a 90-day sort of process in. Every 90 days, look at the permissions that haven't been used, do a bit of a review on should I remove them or not. We haven't gone to the level of automatically removing them yet because we're a little scared, but that is something you could go to in the Nirvana land. Cool. Any other questions? No? Cool.